In this first video, we're going to look at what is a function. So the learning goal for this video is, can I define a function and a relation, and can I determine if a relation is a function? So first, let's look at a couple of these definitions. We've been dealing with relations since grade 9. We want to see if some of these relations are now functions. So a relation is a rule describing the relationship between two variables, an independent and dependent variable. So the lines that we studied in grade 9 were all relations. The quadratics that we studied in grade 10, those were also all relations. But now we want to see if some of these fit and are functions. So a function is a relation in which each value of the independent value, which is usually our x value, has one unique value for the corresponding dependent variable's value. So the independent variable was our x value, and the dependent variable was our y value. So we're going to look at a couple instances here. How can we tell if a graph represents a function? Now, if we think back to the definition from that previous slide there, by definition of a function, every x value has only one y value associated with it. So over here, this was like this one over here, number 1. This was our line from grade 9. If we assess these things with the vertical line test, so if we draw a vertical line anywhere on this graph, and a couple of my lines aren't perfectly vertical, but I think you're getting the idea. If it crosses the graph in more than one place, it's not a function, because that means that there's more than one y value associated with that x value. So these lines that we dealt with back in grade 9, these are a function. So yes, this is a function. If we look at a horizontal, a vertical line rather, these, if we draw a line down, it is crossing at every single point as I'm coming down here. So this one would not be a function. As well as in grade 9, I believe, we looked at a circle. If we drew a vertical line through a circle, I'm crossing at 2 points, one up here and one down here. So this would also not be a function. Okay, so if we have the graph of any function, we can use this vertical line test and draw a line anywhere. If we can do it in any spot on the graph, for example in this circle, I could draw a vertical line over here and it's not crossing the circle in two spots. But if I do it anywhere on the graph and it crosses in 2 spots, it is not a function. So a function has to pass the vertical line test. So another way to represent a function, what may be a function, we'll have to check in this one, is with a table of values. We've seen a table of values before, and we know that these are a point that we could graph on this Cartesian plane here. So let's graph this one and see what's going on. It's got, before I keep going, it's got our domain and range down here, which will be the topic of the next video. But if we look at the y values, the x values, which make up our domain, we've got 1, 2, 3, and 7. So for this, the domain is just that. It's this set of 1, 2, 3, and 7. The range of y values is 5, 6, and 8, and we only need to write 8 once, even though it appears twice here. So let's graph these points. We're going over 1, up 1, 2, 3, 4, 5. There's one of my points. I'm going over 3, 1, 2, 3, up 8, 1, 2, 3, 4, 5, 6, 7, 8. There's another point. Over 7, up 6, 1, 2, 3, 4, 5, 6, 7, up 6, 1, 2, 3, 4, 5, 6, and over 2, 1, 2, up 8 is here, and there is nowhere on this that I could draw a vertical line and hit 2 of these points. So this represents a function. This, yes, is a function. Not all tables represent a function. If we look at this one, same idea. We've got some points here that we could graph and to see what's going on. So at 1 over 1, we're down 2 with this first point. Over 3, 1, 2, 3, I'm up 4, 1, 2, 3, 4. I'm over 1 and up 5. So over 1, up 1, 2, 3, 4, 5. And over 2 and up 7. 1, 2, up 5, 6, 7. Okay, so I've graphed all these points. If I were to draw a vertical line right down here, it would, and my line isn't perfectly vertical, but if you could imagine a vertical line right down this blue line here, it would cross this point here, 1, 5, and this point here, 1, minus 2. So we've got inputted from the x 1, and I'm not sure which value is going to come out, minus 2 or 5. So this is one way that we can tell from a table. We could graph it and do the vertical line test, or if we've got the same x value and we're getting 2 different y values, this also is going to tell us that this is not a function. Okay? So again, if we're looking at function versus not a function, whenever I input my x into some function, here are the possible x values that can go in, here are the possible x values that can come out, or sorry, the possible y values that can come out. When I input these x values, I get these y values. None of them are the same. However, down here, when I input these x values, I input a 16, I can get a 4 or a minus 4. I'm getting 2 different y values. That means this is not a function. So whenever we are looking at a function versus a non-function, we want to look that each x value is, when it's inputted into this function, it is only producing one y value. And if we have a graph, that vertical line test is really useful for seeing if there are 2 y values for any given x value. And that is it for seeing if something is a function.